Well, today I will talk a little bit about my project. It's, I think, subclass characterization and firearms analysis. We'll talk about subclass characterization. That's my main topic. Just my background, I'm from West Virginia University, and I'm a professor in the Department of Forensic Investigative Science there. I've been at WVU now for about 17 years, and prior to that, I was with the South African Police Service Forensic Laboratory. I was the lab director for 6 years there. My main area of research is on firearms and on forensic intelligence. So just in sort of a general sort of idea of the objectives for my project is we're going to manufacture breech face inserts using a variety of machining techniques. I'll go a little bit into the way we're going to use them. And the reason for manufacture is to enable us to produce a large variety of surrogate firearms, as it were. We are focusing on cartridge cases. There seems to be quite a lot of work done on subclass for bullets, but it seems that more on cartridge cases would be quite beneficial. And obviously we're going to do a bunch of test fires with those, and we'll have a set of physical breech faces and a set of physical cartridge cases. All of these will be scanned using a 3D system, and we will have scans both of the breech faces and of the breech face impressions from the various inserts. And we're going to work with, hopefully, with firearms examiners. I've got a couple of firearms examiners who are going to be collaborating with us in the setup of these samples. And we want to build a GUI which will allow examiners to mark up subclass characteristics on the system. We will be supplying them both with the physical, or at least a double cast of the cartridge case and an image at various stages through the study. And taking those data of markup, we'll be hopefully trying to find some sort of consensus on what is subclass, where it's found, and perhaps develop some algorithm which would aid an examiner in the evaluation of marks for potential subclass. So that's our major goals. What we're busy with at the moment is we're looking at the various production processes being used for firearms manufacture, and we're doing that in-house and assessing the effect. We'll just produce breech faces. We've got no real intent of any subclass being on them. Do some test fires, start sending those out to examiners for evaluation, and we will obviously be characterizing the production processes. Okay, so the firearms that I'm going to be using are really sort of based on these two, and for a particular reason. On the right, we've got a TC Thompson Center Contender G2. It is sold in both a pistol form and in a rifle form, and you can purchase various barrels to attach to the frame, and it's capable of firing both center fire and rim fire ammunition. And you can actually put, if you wanted to, I've seen people do this, put a 45-70 barrel onto one of these things if that's your thing. But we're going to be focusing on 9mm Luger. On the left-hand side, we have a universal receiver, which one of my main interests in firearms research is looking at the source of variability on marks found on cartridges fired by the same firearm. So a universal receiver is very nice. You can, same sort of thing, you can put on a variety of barrels on this. It's heavy, and you can also do some sort of accuracy testing. The same idea with this, and I'll show you some more details. We can also put different breech face inserts onto this and thus characterize different manufacturing methods. So here in the side of the TC Contender G2, this is called, they call it the firing pin insert. This is the rear of it. The hole at the top here is for orientation. And then the two holes on the bottom, the center one obviously for center fire and the lower one for rim fire. And in the diagram on the right here, you will see part number 1414. That is this firing pin insert, where it has the two firing pins and springs, and these attach with a bolt into here to position and to retain it. So at the bottom kind of looks what the firearm looks like. We've got this set up in a slightly different way to provide more sort of suitability for firing. So these discs you can buy. You can buy them. I think the last time I looked, they cost about $4 or $5 each. So they're not too expensive. And this is a view of the universal receiver over here, and I'll show you the parts in the next slide or so. We've got a barrel inside here. This is a 9mm Luger barrel. It's a pressure test barrel, and we can screw in a piezo sensor for measuring chamber pressure, and it's locked into the receiver itself with this big nut here. This barrel is about 6 inches long, and here's just a view from the sides. This piston that we see on the right side here, which comes up, and it will align the firing pin with the center of the cartridge. And on the right hand side is the very rudimentary sort of firing system, which I will demonstrate to you as well. So here is in pieces. The ram over here is a little lever to raise and lower this ram. Here's the insert for the barrel, an alignment knob over here, and we can see the breech face insert this section over here. A retaining collar which goes around the barrel, and then this screws into the front of the receiver to hold the whole thing together. So here is our universal receiver. We've got it mounted to a big block of steel. It's about 1.5 inches thick. Did that video just play, or am I doing something wrong here? All right, so I'll play a video of firing this thing. You can put a cartridge in, raise the ram into position, cock it, and pull back, and then it'll release it. You might have noticed here at the discharge, there's a bit of a flame which comes out the top. Over there, that's just we were firing without the pressure sensor inside, so we've got a bit of a discharge here. Just the indoor range, which we have at the university for our research purposes. So let's have a look at a couple of these breech faces, which are the ones which we get from the manufacturer. This is a TC breech. Say again, this is the universal receiver breech face. We got these sort of semi-parallel lines over here. Obviously, a lot of like markings on it. And here is from the Thompson Center for the center fire and the rim fire firing pins. When we manufacture these, we're going to remove the rim fire one and just not have a firing pin in position. Just a takedown, this is what it looks like. The ram removed now. This is the breech face insert. It's connected with these two bolts. There it is in the ram, firing pin coming through the back here. These are the firing pins. This is the one that's from originally manufactured. This is the one that we've manufactured, and so we can process these as we need to. We've changed the size of the firing pin. It was quite large and was not giving us a very big breech face impression to work with. So we've reduced it in size somewhat, and it hasn't had any effect on the functioning of the system. Here's one from the various dimensions. We've got these numbered, place for the firing pin, and you can see it's got like a finishing on the metal and a side view. So just to go through to a couple of methods of manufacture, I'm sure we're all aware of these. Broach cutting leaves pretty large marks, milling and sanding, similar to what is done in the high point pistols. So we want to have a look at those. Here is an example of 3 or 4 successively broached surfaces. So number 1 on the left, 2, 3, and 4 on the right. And we can see these markings, they're quite gross sized markings, which kind of would be indicative of subclass, but we see these gross markings running through all 4 of these pieces of steel. Basically, they are discs which will be ultimately converted into a breech face, but we're just looking at the machining processes for the moment. So we can see that there looks like a lot of subclass. And what we do, we'll be doing with this when we get through successive finishing activities, we will have breech faces which have gone through part of the process. We were in contact with Smith & Wesson and went on their standard for manufacture for their kind of steel that they use and their processes. Here is one on successively milled surfaces. So using an end mill, you can see a bit of tear out in the center here because our linear velocity is a lot slower here, and that typically results in tear out. But we can see quite similar markings on these 4 successively machined surfaces. So would look like there is definitely the potential for subclass on these. Here we have 5 successively sanded surfaces, and you can see them in sort of columns here, 1, 2, 3, 4, and the 5th one. And there doesn't seem to be much similarity between these various surfaces, which is what is kind of expected. So the next step, which we are going to typically be using in breech face or in development of these surfaces, we have two main finishing processes. The first, ceramic tumbling. They dump a lot of these firearm parts into these huge vats, and they will tumble them with ceramic media. The ceramic media, depending on what kind of finish one would want, can vary in size and shape. There are triangular and square, small and large sort of ceramic chips. They're pretty uniform in their sizing in each of the categories. And so the image on the left is a relatively newly produced breech face, and the one on the right was tumbled for about 15 hours, and we can see the sort of pock marks on the surface from some of the media. I'm not really certain what caused this sort of vertical cut, but there are some remnants of the circular marks from the initial. This was turned on a lathe, so from the initial marks on the lathe at the bottom right and sort of the top section, we can see some of those marks remaining, but it causes quite a rough surface, relatively speaking. And obviously, the longer you finish them with ceramic tumbling, the less carryover of subclass will be seen. Here is a second one. This surface was also turned on a lathe. It has been through some finishing using the ceramic media, and then on the right hand side it's been finished with a glass bead blasting. And so we get this sort of very what's the word, high sort of like renderness on the surface from the glass bead blasting. So two finishing techniques which we will be studying. At the moment, we're just for purposes of comparison. We've got a surface. We have the surface A. After manufacture, we ran it for 2 hours with the small tri-cut ceramic beads, and then for 2 hours with the large tri-cut ceramic beads. And in the second one, we added another 4 hours of the large tri-cut ceramic beads. And so this is run through the NIST CMC algorithm. And so basically for an introduction to that, it's going to have a look at the surface, and we're going to remove parts which are not going to be compared. So in this instance, one would take out the firing pin impression. If there was any active shearing, we would remove that. If there are any areas that are very much different from the average height of the surface, those would need to be removed. And then what it will do is it will take the surface and it will divide it up into a number of cells, starting at the bottom here, A1 up through A34. And you can specify the number of cells that you want. It will undergo some filtering. This one has had a low pass filter, which is going to remove any sort of like higher frequency artifacts, and then the high pass will have a wavelength of about 400 micrometers to take off those artifacts. So sort of, gentle kind of curvature to the surface. There are certain criteria to ensure that whether a cell is congruent with another cell. And the first one is cell similarity. So the cells have to be similar by at least 20% of the surface area. If you didn't have that minimum, and you could end up with a situation where, say, only 0.1% matches, but it matches really well, and that's not really very useful for us. Then cell position. So on the compared surface, the cell cannot be further than, in this instance, 125 microns in the X and the Y direction away from where the other cell was. And then thirdly, we have a variance of 3 degrees in the rotation of the cell. And so you don't want it to be rotated too much. And the positioning of those cells in the rotation are very crucial in the determination of whether a cell is congruent. So basically what it's done is it takes cell A, it gets the part of the image which is available in cell A1 at the bottom, and then it searches across, down, and rotates as well to find the best spot which has the highest similarity based on these requirements here. And so A1 found the best similarity and it fulfilled these requirements at position B1. Similarly for A2 to B2, and so on. And so we had 34 cells in our reference image, and we have 34 in our compared surface. If we go to another one, we've got 2 finished surfaces with a long time of tumbling, surface 1 and then surface B, A rather, and then B. And we can see here that we've got the same sort of setup, same criteria. And we can see that on the reference surface, it shows how these positions are marked. If they're marked in black, then that would indicate that they fulfill the requirements to be congruent. If they're marked in red, then they don't fulfill those requirements. So if we look at cell number 18, A18, it's 3 up from the bottom at the extreme right. And if we look at the reference surface on the extreme top edge, we will see B18 there, completely different position rotation, and so on. So this is how it looks for similarity between these. Now, when it comes to subclass, it's really going to depend on the kind of subclass that we're looking at. We will have to go through a full validation of a determination of subclass. If that is doesn't work so well, we'll have to develop a new measure for evaluation of subclass in a quantitative fashion. So what I hopefully will doing is in the next couple of months of the summer and into the fall is complete the manufacture of our breech faces. We'll have our team to complete the evaluation of the samples. We want to distribute them to examiners, and we're going to start developing our GUI. Okay. All right. Are there any questions? So from Jordan, what is the benefit of making your own breech faces versus purchasing slides from a manufacturer? Well, the advantage is, well, the advantage of purchasing from a manufacturer would be they are manufactured specifically according to that manufacturer's process. The downside is if manufacturer uses an investment casting or whatever method they use of manufacture, then that's the only way I could get those slides. So I wouldn't be able to get as wide a variety of manufacturing methods, and I would have to go to another firearm, which would then also not give me the other manufacturer's manufacturing method. So it allows us to sort of tailor what we need to have in order to get the variety of manufacturing methods. And it's a lot cheaper. We'll also be using our ammunition. We'll be using specific cartridges, the same primers and powders for these. As you may probably be aware, trying to acquire ammunition and ammunition components and even firearms these days is pretty difficult. So we were able to acquire quite a large number of cartridge cases, which is going to help our study. All right. Jordan had a follow-up about the double casting. We're going to be sending the double casts to the examiners because we only have, we've got only one specimen of a particular cartridge case. We just recently, one of my previous PhD students, Eric Lorna, published a paper where we did a previous study using double casting to assess we've done quite a bit of work on the assessment of the reproducibility and repeatability of double casting. We hope, if needs be, we still need to decide whether we'll actually send examples, casts of the breech faces themselves as well. What are we going to be asked as part of the evaluation? So the evaluation is going to be, here's a cartridge case that might be from a crime scene. What features are you looking for during that examination? And we will be wanting the examiners, when we have the GUI in place, you can put the image up there. You would have your cartridge case to the double cast of the cartridge case to hand, so you could actually put that under your microscope, take a look at it, and then any features that you would think are important to look at, you could then mark them up on the GUI. The markup on the GUI then would automatically give us all of that information that you've recorded. Okay, well, thank you everyone for coming. I appreciate your time. If you've got any questions or you have anything else you'd like to discuss, please feel free to contact me.